If you punch 5 times 5 into a calculator, you get 25.
Right, yeah.
It is a clean, mathematically indisputable answer. But if you ask an artificial intelligence a complex question today, you get, well, kind of a murky, hallucinatory landscape.
Oh, absolutely. Very murky.
Today, we have a stack of project notes from an AI engineer named Kunal Patil, who decided to fix that murky landscape by forcing AIs to literally fight each other for the truth.
Yeah, he calls it the AI Agents Battleground. And it's a fascinating architectural leap.
Okay, let's unpack this, because we are not talking about your standard chat interface here where you just type a prompt and, hope the model gives you a decent summary.
No, not at all.
Patil is building a dynamic, combative arena. The mission for today's deep dive is to figure out how this works, why multiple AIs arguing might be better than one AI summarizing, and, well, what this means for how you will interact with information in the near future.
Right, because the current way is just broken.
Totally. I mean, think about the last time you went down a rabbit hole trying to research a major financial decision or like a complex medical issue.
Oh, it's a nightmare.
You are instantly hit with walls of text, conflicting studies, half-truths. It is completely overwhelming.
Yeah, and standard AI models don't actually help with that overwhelm because they try to be everything to everyone.
Right.
If you ask a standard large language model about the economic impact of, say, renewable energy, it defaults to a middle-of-the-road, watered-down summary just to avoid being wrong.
It just averages out the nuance.
Exactly. It averages it out. But Patil's approach shatters that single-voice paradigm using multi-agent systems.
Mm-hmm.
Instead of one omniscient AI trying to do everything, the system spins up multiple distinct AI agents to examine the problem.
But before we throw these agents into the ring, we need to understand who exactly is fighting. Because Patil isn't just throwing 3 identical generic bots into a room and telling them to generate text.
No, he's utilizing a framework called role-based reasoning.
Right. The notes specifically mention assigning personas, like an economist, a scientist, and a strategist.
Yeah, and adopting a persona in this context, it acts as a highly restrictive cognitive filter. It fundamentally changes how the model retrieves and values information.
Wait, I am going to push back on that a bit. Underneath the hood, these agents are all pulling from the same foundational model, right?
Well, yes, technically.
They are pulling from the same massive internet-trained database. So does telling an AI, you are an economist, actually change its fundamental logic? Or is it just, putting on a metaphorical suit and tie and throwing in words like amortization and fiscal to sound the part?
That's a great question. What's fascinating here is the underlying mechanics of how we constrain these models. When you assign the economist role, you are altering the system prompt to structurally restrict the data pathways it prioritizes during its retrieval phase.
Okay, so it's not just a vocabulary swap.
No, not at all. The economist agent is mathematically instructed to assign higher vector weights to historical market trends, cost-benefit analyses, and resource allocation data.
Oh, wow.
Yeah, it searches its database differently than the scientist agent, which is heavily weighted toward peer-reviewed methodologies and physical constraints.
So they are literally looking at the world through different mathematical lenses.
Exactly. The role dictates the evidence they consider valid. It forces the AI to abandon the watered-down summary and take a hard, specialized stance based on those weighted parameters.
Let's ground this with a concrete example.
Sure.
Say you want to explore the viability of universal basic income. Our economist agent looks at the data, weighs historical market trends, and argues that universal basic income will cause massive inflation and devalue the currency.
Right.
Meanwhile, the strategist agent looks at the exact same policy, weighs long-term societal planning, and argues it will free up human capital for higher-level innovation, leading to a net positive GDP in a decade.
Because of those different vector weights.
Right. They are looking at the exact same issue, but their structural constraints force them to value completely different outcomes. It's like a high-speed, automated Model UN where the delegates have incredibly rigid priorities.
Yeah, but if you put 3 highly specialized delegates with rigid priorities in a room and just tell them to talk, you don't get a debate. You get a shouting match.
Fair point.
In the context of large language models, 2 models talking to each other without constraints will usually spiral into an infinite loop.
Oh, I've seen that happen.
Right. They either endlessly generate variations of, that is a great point, I agree, or they drift entirely off topic into pure hallucination.
That natural chaos necessitates a very strict set of rules, which is where the underlying architecture of Patil's project comes into play. The notes highlight two major frameworks carrying the load here, LangGraph and AutoAgent.
Yes.
The system uses multi-agent workflow orchestration to organize the chaos into structured debate rounds.
And workflow orchestration is arguably the bedrock of this entire project. LangGraph is a library designed specifically to manage the state of a conversation between multiple agents.
Managing the state. Break that down for us, because I am picturing like an invisible debate moderator or maybe an air traffic controller.
Yeah, that's a good way to look at it.
The controller doesn't just tell planes to fly, it assigns runways, sets holding patterns, and dictates exactly who moves when.
The air traffic controller analogy is a great way to visualize it, but let's look at how the code actually executes that control. LangGraph operates using a system of nodes and edges.
Okay, nodes and edges.
Think of the nodes as the agents themselves, the economist, the scientist,
Not it.
and the edges as the highly specific conditions that must be met before the conversation can move forward. LangGraph creates a literal, step-by-step computational checklist.
So it's very rigid.
Very. It doesn't just let the models generate text freely, it holds their outputs in a temporary memory buffer.
Oh, so it is physically pausing the models and controlling the flow of data between them.
Exactly. It creates boundaries.
Yeah.
So The Economist makes its opening claim about universal basic income causing inflation.
Right.
LangGraph captures that text, freezes the Economist agent, and updates the shared state, essentially the central transcript of the debate.
Okay.
Then, the edge logic dictates that this updated transcript must be passed to the scientist agent, along with a highly specific automated prompt, like, review this previous claim and formulate a targeted counterargument based on your specialized parameters.
Wait, really? So instead of just predicting the next word in a vacuum, the system is forced into a reactive loop.
Yes.
The agents have to actually process what the other one just said.
If we connect this to the bigger picture, this orchestration elevates an AI from a static question-answering tool to a conversational ecosystem. The workflow forces the agents to read, process, and directly address the specific arguments made in the previous round.
That is wild.
The ideas actually evolve through iteration, rather than just being a singular response to your initial prompt.
That structure is brilliant. But, I mean, having beautifully structured rounds of debate doesn't mean much if there isn't an actual resolution at the end of it.
Right. Somebody has to win.
Yeah, you can't just have an economist and a strategist trade blows endlessly. Eventually, somebody has to call the fight and declare a victor.
And the system handles this by introducing a dedicated judge agent.
Right. According to the project notes, this judge uses a specific judgment and scoring mechanism to evaluate the arguments based on 3 distinct criteria: logic, evidence, and rebuttals.
Yes.
But here's where it gets really interesting, and frankly, where my alarm bells start ringing.
Uh-oh.
How does an AI objectively judge logic? I mean, human Supreme Court justices struggle every day to define what constitutes sound logic.
Very true.
Furthermore, how does the code weigh the hard, empirical math of the economist against the big-picture theoretical philosophy of the strategist? You are comparing apples to conceptual oranges. How does a scoring mechanism reconcile that difference in data types?
It is the hardest problem in AI orchestration, hands down. And the scoring mechanism doesn't necessarily solve it by trying to perfectly balance the opening statements against each other.
Oh, it doesn't.
No. The brilliance of the judge agent lies almost entirely in that third criteria, the rebuttals.
The cross-examination.
Exactly. The judge is meticulously evaluating how well these agents defend their positions under pressure. It is specifically programmed to look for logical fallacies and semantic inconsistency during the defense phase.
Let's go back to our universal basic income example to see what that actually looks like in practice. The economist claims UBI causes 15% inflation.
Right.
The LangGraph workflow pauses, hands the transcript to the strategist, and the strategist pushes back, demanding the economist show the historical precedent for that specific 15% number.
And then the workflow hands the mic back to the economist and forces it to respond to that specific challenge. This is where the judge goes to work. If the economist has real data, say, it cites a specific historical stimulus package and accurately maps the corresponding inflation curve, well, the judge agent scores that interaction highly for evidence and logic.
Because it held up.
Exactly. But if the economist gets cornered and hallucinates a fake economic study or contradicts its own earlier statement to cover the gap, the judge catches the structural inconsistency.
So the judge isn't just grading the initial data drop, it's grading the structural integrity of the argument under stress.
Yes.
Did the agent adapt logically to the new information, or did it crack and start making things up?
The judge evaluates the chain of reasoning. Did Agent A actually address the flaw pointed out by Agent B, or did it just deflect?
Wow.
The AI assigns a numerical score to these specific interactions, tallying points for robust defenses and deducting points for logical fallacies like ad hominem attacks or straw man arguments. That is how it determines the overall victor.
Think about how powerful that concept is for you when you are navigating the news or researching a dense topic. We usually look at who makes the slickest opening argument or who presents the most colorful graph.
Yeah, we're suckers for a good chart.
But the real test of a claim is whether it survives a targeted, informed counter-argument. A good point is only as good as its ability to withstand a rigorous rebuttal. Patil's Battleground automates that exact stress test at machine speed.
It functions as an automated stress testing engine for ideas.
And the speed isn't even the most mind-bending part of this. The truly defining feature of the AI Agents Battleground isn't just the mechanics of the judging, it's the complete and absolute absence of human oversight in the process.
Total autonomy, from the opening prompt to the final gavel.
The notes are explicit about this. The system is fully autonomous. The agents generate the initial arguments, they formulate the relentless rebuttals, the judge scores the interactions, and it spits out a final conclusion completely without human intervention.
It's wild.
So what does this all mean for us? It means you can type in your prompt, like, debate the long-term viability of universal basic income. Hit enter and walk away. You go make a cup of coffee. You do not intervene.
Which is, this raises an important question about our current relationship with artificial intelligence.
How so?
Most of us are used to what I would call needy AI. You type a prompt, it gives you a mediocre answer. You have to constantly massage the prompt, tell it what it did wrong, ask it to rewrite specific paragraphs.
Then manually steer it back on track.
Yes. It is an exhausting manual loop.
You have to hold its hand the entire way.
Peel's architecture completely removes the human bottleneck. We're looking at a closed-loop system. The value here isn't just generating text quickly. It is the ability of the system to self-correct and refine its own output.
Right.
When the judge agent flags a weak rebuttal during round 2, the system uses that feedback natively in round 3. It is an AI ecosystem pressure testing its own outputs without waiting for a human to tell it what to do next.
And picture what an incredible intellectual proxy that becomes. Going back to that feeling of massive information overload, when you are trying to understand a new medical treatment or a complex piece of legislation, you currently have to play the role of the researcher, the skeptic, and the judge all by yourself.
It's a full-time job.
It is exhausting. And let's be honest, we all have our own biases. We naturally tend to favor the data that supports what we already believe and ignore the rest.
Absolutely. A system like this bypasses that confirmation bias. It synthesizes the terabytes of conflicting data, forces specialized personas to try and dismantle each other's arguments, and offers you a fully vetted conclusion.
Which changes everything.
It shifts AI from being a passive retrieval tool that just fetches documents into an active truth-seeking engine. It filters out the intellectually weak arguments before you even sit back down at your desk.
Okay, let's pull all these threads together. Kunal Patil's AI Agents Battleground is fundamentally redefining how we extract truth from large language models. By using LangGraph and the AutoAgent framework, he has built an orchestrated arena where AI adopts highly restrictive, specialized roles like an economist, a scientist, or a strategist. Right. These agents don't just passively summarize data, they argue in structured rounds, passing context back and forth and actively trying to dismantle each other's claims. Finally, a dedicated judge agent scores the debate, not just on the opening evidence, but on the logical integrity of the rebuttals. And it executes every single piece of this complex workflow autonomously.
It is moving beyond artificial intelligence and inching toward artificial reasoning. The machine isn't just fetching answers anymore, it is weighing them against each other.
It really is. But stepping back from the impressive code and the orchestration, it leaves us with a rather haunting thought to mull over as we wrap up. If we can successfully build a fully autonomous system, one that generates its own evidence, formulates its own relentless rebuttals, and uses an entirely impartial AI judge to score the final conclusions without an ounce of human bias or intervention, well, what happens when this battleground reaches a flawless, mathematically logical conclusion that completely contradicts human intuition?
Wow.
We started this deep dive talking about the comfort of the calculator, how we want machines to just give us the clean, obvious answer. But when the AI courtroom finishes its murky, complex debate, and the AI judge finally bangs the gavel, are we actually ready to accept its verdict?